Hey folks, welcome to Advent of Code in F Sharp, day 5. So far so good. We've got all our stars, so let's take a look at that. If you give a seed a fertilizer, that's a decent description. Let's go. You take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source? Island is the water source. You point out that Snow Island is not receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no, his face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forget to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another problem. The latest Island Almanac just arrived and we're having trouble making sense of it. The almanac, which is our puzzle input, lists all the seeds that need to be planted. It's some Stardew Valley stuff right there. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Okay. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, we have soil 1, 2, 3 and fertilizer 1, 2, 3, and they might not be related. That makes sense. So let's take a look at this almanac. We have seeds, we have a lookup from seeds to soil. We have lookups, 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 lookups. So we have a lot of lookups. The almanac starts by listing which seeds need to be planted. Yeah. The rest of the almanac contains a list of maps, which describes how to convert numbers from a source category into numbers into a destination category. That is, the section that starts with the seed to soil map describes how to convert a seed number, which is the source, to a soil number. This lets the gardener and his team know which soil to use with which seeds, yada yada yada. Okay, but what do the multiple numbers mean? Rather than list every source number and its corresponding destination number one by one, the maps describe ranges of numbers that can be converted. Each line within a map contains 3 numbers: destination range start, source range start, and the range length. So consider seed to soil map. First line has a destination range start of 50, source range of 98, and a length of 2. This line means that the source range starts at 98 and contains 2 values. Destination range is the same. Okay, so that's a roundabout way of specifying a map, but I get it, cool. So then we know that seed number 98, which is the first one, corresponds to soil number 50 and 99 to 51. Okay, so it's a direct mapping. Probably we could leverage that and not do a naive thing. Maybe the naive thing will be a bit slow. Maybe. We'll see. Let's try the naive thing first. Okay, so that makes sense. Let's take a quick look at the second example. Maybe there's some hidden edge cases in here. Second line means that the source range starts at 50 and contains 48 values. Yeah, okay, makes sense. Any source numbers that are not mapped correspond to the same destination number. So if we don't find a hit, we map to the same number in the mapped category. And this is a printout of the first 99, cool. And then we can go from seed number to soil numbers. Yes, yes, yes. The gardener and his team want to get started ASAP, so they would like to know the closest location that needs a seed. Using the almanac and all these maps, find the lowest location number that corresponds to any of the initial seeds. So for every seed, we need to find the location. That's probably the final step in the mapping. That's probably the final step in the mapping. To do this, you'll need to convert each seed number through other categories until you find its corresponding location number. And then we just find the lowest location number. Okay, makes sense. Let's take a look at our maps. Oh, these ranges are a bit bigger. Sneaky, sneaky. So maybe let's not try the naive approach by listing all the ranges explicitly. No, let's put some intelligence in the lookups. Or maybe let's even think more than 1 second about the problem. Because these numbers are giving me pause. Let's take the example as well, which is teeny tiny in comparison. Example, and let's make sure we can parse everything, or at least read everything. Okay, we can. So, we need to find location number, lowest location number, and for every seed in our input, and it goes through a sequence of mappings. It's a destination range start, source range start, length of the ranges. How can we do this? So, for seed 79, what should we be doing? We need to go into the seed to next thing map, find where 79 lands. Does it land somewhere? Maybe in the 48 range? Yeah, probably in here. So then it maps to soil number 52, and we just continue down the maps until we hit the location. Can we do something smart? We only need to go through it once for every seed, so I think maybe it's not too much of a hassle. Maybe just not list every element in the range and just do a quick, does it fit in this range given the start and the length? But I don't think I'm going to make it more difficult than that for part 1. Let's give ourselves a reminder. How big are these numbers? Is it still integer range? Those are some big numbers. Those are some big numbers, so let's use big numbers as well. Okay, let's start playing around with the problem. How many maps do we have? Is it always the same length of maps? Seed, soil, soil, fertilizer, fertilizer, water, water, light, light, temp, temp, humidity, humidity, location. I think so. Okay, so let's just hard code the kinds of maps in our parser. We don't need to get too fancy here. So let's start by parsing as always. I want to parse out a list of seeds, and every map I just want to have like start range, length. Yeah, let's keep it simple. So let's first parse out the seeds. It's just the first row, right? And let's get rid of the unnecessary part, and let's split on space so we grab out the individuals. Why is this not working? What is the type of... Oh, what's the type of this? String? Yeah, we should be able to split it. Maybe some parentheses in there. Yep. So then we have our raw numbers, and let's map a long parser over there, or an unsigned int64. And it's not a list, it's an array. But I like working with lists, so let's do a two lists. 79, 14, yada, yada, yada. Cool, we have our seeds. And then we can just do the same for parsing a map. Yeah, so let's start parsing maps. So I'm using, I don't even know what the name is of this, slices to get rid of some first lines of the example here. So this is the rest of our strings containing our maps, and they are separated by new lines or by empty strings in the way I parsed our initial string here. So let's group by or take while. How do you do this? How do you take everything up until an empty string and then continue? We have some splits, we have some chunks. Is that something we need? No. Split. We can split at indices. Nah. You have partition, that's also not what we need. We can do take while and do it recursively. We can do take while and do it recursively. And maybe that's even more explicit. So let's do the first one, seed to soil, which grabs whatever and then says take all the lines while the lines are not empty strings. Oh, we're already in list world. We have left the array world, people. So yeah, we have our seed to soil map, 2 lines, that is correct. I'm just gonna get rid of the seed to soil as well. And we can now parse all the maps. What would that data structure look like? Just the raw data, I guess, yeah. So map is a list of entries, and an entry is what's the order again? Source category, destination category, yes. Seed numbers are up. Okay, there we go. So we have destination range start, source range start, and range length. Why swap destination and source though? So we have, let's keep everything in the same type. Destination start and range length. So our map will be a list of entries, and this is what an entry looks like. And now we can parse our entries. Again, helper function to parse an entry. And we can just split on space for this. It's always 3 elements long, so let's not make it too difficult. That is destination start, source start, length. And we can just split on space. And then we can return one of those entries, which flips them the right way around. Not that the records have like an order, but at least then it reads better in my head. Range length should be length. And they should be uints, not strings. So let's map over them. There we go. Let's see if we can parse our seed to soil map here. From 98 to 50 at length 2. Yeah, looks great. I'm gonna hint at the type here. So we are building maps. And then we do this a couple of times, I guess. Should we have split the maps into different chunks before we started doing this? Maybe that's cleaner. Otherwise we have to count whatever we parsed and skip that many. So yeah, quick sidebar. I'm first gonna chunk the input into like its distinct parts. And then I'm gonna run these parsers over them to keep it a bit cohesive. So instead of dropping right into the C2 soil map, let's first chunk the input a bit into different maps. So we are gonna try doing the recursive take while thing while we hit this and then we stop. So how does that work? Yeah, I'm just gonna write a function. Let chunk input by separator. Is there no chunk by or no built-in thing? No, it's only by size and we don't know the size, or the sizes are different for all our maps. So yeah, let's build it. Let chunk by equal. And that chunks the lines into a list of lines, right? So that should be the type signature. We get a separator, we get some lines, and it chunks the lines. Okay, probably going to be recursive. So the next chunk equals lines. And we take while we don't hit the separator. And we can write that shorthand. So take while we don't hit the separator. So that would be, in our example, it takes this and then stops. Or let's take a look at a map. That's a more interesting example. It takes this, it takes this, it takes this, and then it stops. And then the rest is lines. And then we just skip whatever we saw and we skip just the one more. For the last one, it won't be possible to skip one more. So let's just do a hacky thing and skip the first thing. Yeah, let's just skip the first thing and give this function the empty string at the start. So yeah, this is the rest, and we can chunk recursively with the rest, and we can provide the chunk in the result. We're not doing tail recursion. We can do that. We know how to do that. We saw this in one of the previous days. So this is a chunking function. Let's do a quick test on this chunking function. So if we chunk by 10, or maybe let's use strings here, A, B, empty string, C, D, and let's start with the empty string because we put that in there deliberately. Yeah, is this doing what we wanted to do? What's the separator? Sorry, empty string, of course. Oh no, it looks like an infinite loop. Oh, of course. No, I'm not seeing it actually. What's the infinite loop? Why our recursion does not stop? That means we're not making the problem smaller. That means that rest is not shrinking. It means that our skip, that our length is 0. So why is this 0? I don't know. Let's look at what's happening here. So I'm gonna name this thing lines. And then do lines skip 1. That should not be a problem, right? Cool. And then take while we don't hit sep. Sorry, sep is empty string. So this should give us AB, that's correct. and the rest should be everything after that. Oh, we're not skipping enough. So if we have a chunk of 2, oh yeah, that's because this skip 1 is in there. Ah. Okay, so maybe this works better. It does not. AB. CD. Okay. Let's take a look at the exception. Index is outside of the legal range. And what are we trying to do? Line 66. We're trying to skip one of the empty list, probably. So yeah. This is more like it. We can chunk by a separator now. Handy built-in function that did not exist. I'm not super happy with the implementation, but it works. So I'm not gonna pause too long on it. And let's write this into a test. So chunking this should give us A, B. Were we to use this like in real code, I would not do the hacky, you have to put in this empty string as first element, but for additive code, this is more than enough. So let's see if everything still works. Text is not defined. What is it trying to say? I think it's trying to say that I'm faster than a... Oh no, I did not import my unit test library. Yeah, there we go. So, quick roundabout or quick detour to chunking. So now at least we can chunk our input. Chunk by empty string, and let's chunk the entire example. I think that's okay. Yeah, that's good enough. So let's grab our first parsing thing, our seeds here, all the rest is useful. And let's do the parsing after the chunking. So our chunks are this, and our seed to soil map. Our seeds are gone already, is that okay? Where did our seeds go? Does example not contain seeds? It does. So our chunk gets rid of our seeds, that's that was not by design, but okay, not worrying about it again. So our chunks. Oh, sorry, I'm touching on seeds, but I don't need seeds. That was okay. It's the maps that we're doing here. So how do we parse out maps of these chunks? We take our seed to soil map, right? Which is 3 lines, so that is chunks first element. That's the chunk we're looking for. It's crashing because we're trying to parse an entry from the title of the map, so let's just ignore the entire entry or the title, and that should still work. Yeah, okay. So now we're set up to parse everything. Okay, what's the second map? Soil to fertilizer. That should probably be the next chunk. Yes. From 0, 39 and take 15, is that correct? No. Oh yeah, I was looking at this 15, I was getting confused. Okay, so let's continue on with all maps. So that's what? Seed to soil, soil to fertilizer, fertilizer to water. And we just keep doing this. Water to light. Light to temperature. This is where I'm losing a lot of time, but we're not doing this for a speed run here. Light to temperature, temperature to humidity. Just parsing along. So yeah, I think we parsed our maps. Then we have our seeds, then we have our maps, then we can run our maps for every seed. And we can just feed our identity or our numbers through each one of those maps. That's actually cool. It's gonna look cool in F#. Let's build a mapping pipeline. So let's take the first seed, for example. So we have our seeds. And let's grab the first seed. How would we run our seed through this map chain? Is there a term for what we're going to do? Corresponding, we're looking up corresponding numbers in the maps. Yeah, let's do lookup. Let's call it looking up something in a map. So let's look up what value this seed should get soil-wise. So let's look up in a map and an ID, or what are those numbers? Yeah, let's call it number. So let's write a helper function that takes a map and a number, and it always returns a number, depending on whether or not we find a hit in the map. And let's give it this some hints. So a map is a literal map type that we introduced. Yeah, and then we can get started. So our map is a list of entries, so we can try to find an entry where entry dot we need to find the entry where our number is in the source range, right? Yes. I'm gonna need an example to make this concrete in my head. So let's grab our seed to soil map. And we need to find an entry that matches, and for whatever seed we had here, for 79, do we have a map? 52 plus 48, so I think we do. Do we have an example maybe we can start to look at? So second line, that's what we're looking at. It contains, sorry, source range contains values start at 50, length 48, so it starts there, ends there. So seed, whatever it is, seed 79 is definitely in there, so it should map to the destination range, right? Maybe we should take the literal example in order to not confuse ourselves. Seed 53 maps to soil 55. Soil 55, and let's put it in a test. But I'm doing TDD right now, but I'm not encoding it in the test. I'm just playing around until I see 55 come out of this lookup. So it should be lookup seed to soil, and we're looking up seed number 53, and that should give me a 55. So yes, I am writing a test actually. This is what I want to see. Okay, let's do this. So we try to find an entry where it's in the source range. The number is in the source range of the entry, so let's write a helper function yet again. What was the type? It's entry. Okay, so let's call this an entry. Do we need a true false, or can we skip a step and already? No, we need true false. We need to find the correct entry if there is one. Okay, then it's an easy, let's give the compiler a type hint here so we can use auto-completion. Source start. So number should be in this range, so it should be smaller and equal to source start, and it should be, or should be bigger or equal or smaller or equal than the end, and the end is, I'm sure you can do all kinds of fancy stuff, but what is it? Range length, something like this. So it's something like this, but this is very off by one prone. So let's verify. So we have our, let's first take a look at this in source range. It's too important to not have correct. Destination start, I don't care about this right now. So is 10 in the range we're seeing here in the source range? It should not be, right? Okay, I'm sorry, I tried to put a negative number in there. So 10 is not in here, it should be in here. Yeah, it should. Okay, I'm comfortable enough. Let's wrap some tests around this to make sure. I hope my auto formatter knows what to do with what I'm providing here. No, I need to close my quoted expression. There we go. So this works. Let's see if it works other way around. So if it's 10, that should also still work. So I'm taking it slower than usual because I know myself and I always mess these by one things off. Now I think my auto formatter might be losing it. No, it's still good. And let's try our out of bounds in both ranges. So say there's a 7 here and a 2 that should not be in range. Ooh. Yeah, so that's true. Okay, let's put a not in there, so it should not be the case. Yeah, and let's put in one more that goes in the other direction. So whatever. 11 should also not be in range. Yeah, I'm just gonna run all the tests to make sure. Yeah, everything works as we expect, so we're good. I think in source range works. So then we have the entry if there is one. I'm using try find here because if we don't have any entries, we need to default to the number we get. And let's maybe do that right now. So let's pattern match on entry. Yeah, let's just do a pattern match. If we don't find an entry, we can return the number itself. So it's the identity function, and otherwise we have the entry and we can just calculate the mapping, right? So the mapping is for seed to soil. How do we figure out to what number this maps without listing all the numbers? I think we can calculate the offset. So we know the source start, source range. We can calculate the offset of the number we have from the source start. And that's the same offset we need against the destination start, I think. So let's write a helper function yet again. Let's find the corresponding number for our number in entry. So let's write that function. False, oh yeah, because we're not implementing it correctly. So if we have an entry, look up corresponding now. Yeah, so how do we do this? I outlined the idea before, so let's calculate the offset. A number is always the biggest number, so it's number minus entry source start. So that's the offset from source start. And I think if we just add destination start to this offset, maybe potentially, we get the right number. Yeah, so our lookup of 53 is working. I'm gonna plug it in my tests. And that is maybe it for lookup. I think so. I think let's look up. So now let's chain all these maps together. I'm maybe gonna write some more tests for lookup. What if we don't have an entry? It should just echo the number, right? So our seed to soil map is looking something like this. Source start 98 and 2. Let's figure out the number 1337. That should just echo itself. It looks like it's echoing itself, yeah. Ul. This ul postfix is really weird, but it's a shorthand for unsigned long. Okay, so this looks good. The only thing we need to do now is chain all these lookups together, feeding a number through the sequence of maps, and in the naive way, we're done. So I hope this scales to our input. Let's give it a try. So we can look up in a map, feed it in. The order of arguments matters a bit here because we're going to literally build a lookup chain. And if you flip arguments around, it becomes hard to compose functions and partially apply arguments. But I'm talking a lot without showing you code, so let's fix that, shall we? Let's build a lookup chain. And maybe, yeah, I'm gonna start by showing what I'm gonna do. It's going to be a function that takes a number and then does lookup in seed to soil. And that result gets piped to the next thing, and that gets piped to the next thing. So that's the idea. So that looks up the number in the seed to soil map, and that's the first lookup. So let's call it lookup 1. And then we can look up in the soil to so the fertilizer. I don't know why my autocomplete finds it too hard to find that. Oh, because I forgot an equal sign and they have no clue what I'm trying to do here. Okay, so this is a chain I'm trying to build for all the lookups. And that's one way to write it, but that's a boring way to write it. I was hoping I could do something like this. So lookup in seed to soil and then pipe that result to lookup in stuff like that. And there's maybe even other ways to write it even more dense, but this is good enough for me. So yeah, I think this will work. If you look at the type now of this lookup chain, it's a function that takes an unsigned integer and returns an unsigned integer. So that is exactly what we need. So we can build the entire chain in this very cryptic function composition kind of way. And we haven't seen that this year, so let's give it a try. And this is the fertilizer to water map. And we just continue on. Almost there. Almost there. And we have locations. There we go. Let's have our auto formatter clean things up. So this is our beautiful lookup chain. I think we're almost there then. What do we need to do? We need to map every seed number to the end of the chain to the soil number. And we need to find the lowest one of our seeds 79 through 13. So let's give it a try for the example. 79 through 13, yeah. So let's map that to the lookups. So let's look up everything in the chain. 81, 53, 57, 52. That does not. 82. That does not look correct. That's a shame. But that's not a problem. We probably have enough by one in there somewhere. And we can show how I debug or troubleshoot pipelines. So that's a great example of how to troubleshoot pipelines. Because why is this a bit tricky to troubleshoot? There's no temporary variables to print out. It's all one generic function lookup. So if you want to print out something in one of these cases but not the others, it becomes really tricky. But there's a trick, and that is plugging in extra logging functions into this pipeline. So let's give that a shot. Let's build a chain debugger helper function that we can plug into this thing. So I would like to print out, or we can show all the intermediate lookups, or we can just plug in a print function that shows it. Let's do the intermediate function. So the debug function is just the identity function. It takes whatever and it returns whatever. And then you can plug it in wherever you want to. And it still compiles and it still does the same thing. But now we have like a hidden function where we can do some secret side effects like printing. So we can give it an argument like message, and we can say seed to soil. That all still works, still the same visible output, but we can also do stuff in this function, and that's where the magic happens. You can print, for example, or you can put a breakpoint, or you can do whatever you want. Somebody asked, can you debug FSX script files in Visual Studio? I believe you can, and we might give it a try if we finish today early. But let's first show debugging with this print, or this debug function, sorry. So we print the message and we print whatever we get in our input. So if we run this code now, you see that we're printing out seed to soil is 13. And seeds. Oh yeah, that's the final seed. So that's seed number 13. Okay, so let's print out everything so we know where our bug is. And here we go again. That's a lot of lookups. Water to water, water to light. Light to temp, and temp to humidity, and finally humidity to location. There we go. We have instrumented our lookup chain by just changing the entire pipeline and putting in debug functions, but then we can at least see what's happening. What's the first one? Seed to soil, huh? Oh, sorry. That's not the last one. I'm gonna put a debug in before. So we actually have some separator between the cases here. So yeah, there's a let's go. We start with seed number 13. That maps to 13. That sounds correct. Let's put the example next to it. Soil 13, fertilizer 52, water 41, light 34, temp 34, humidity 35, location 35. That's actually super correct. 68, 43, 82. Okay, there was no bug. I don't know why I got my eyes crossed. There is no bug here. It's all working. And then we just take the lowest. We just take the lowest. Interesting. So yeah, we grab ourselves, we grab the lowest, and that's a number, and that's maybe what we want. I'm gonna silence my debugger, but let's keep it in the pipeline because we have another part coming, right? And this should be 35. So yeah, I'm pretty comfortable. It works for the example at least. But now let's run it on our input. And we were doing everything in a big old script. So everything is using example. Where do we start? This is where we do the actual parsing, right? Let's put example in comments so I know where we're using it directly. So we can wrap some functions around it so it can run on any kind of input. So yeah, this is the parsing bit, and that's using the example. So let's do the parsing bit. And our tests also, I think, use some of these maps, so we might need to fix those up later, but that's not a problem. Actually, we need to return all those maps. Actually, that is a bit of a problem. Yeah, let's do that later. I just want to see if our solution scales to the final scope of the problem, and then we'll clean up after ourselves. So yeah, everything should work if we just plug in input, except our tests, of course, because they were built on the example. Let's chunk. Let's build our maps. That all seems to work. So now we can actually see if part 1 holds up, or our algorithm holds up. Oh, that appeared to be pretty fast, actually. Why was I this worried? We have a solution. Let's make sure, or let's verify whether it's the solution. Oh, that's the right answer first try. That's a good sign. I'm happy that we spent a little bit of effort today checking our off-by-1 errors in our tests, because I am infamous for having that wrong. So before I start cleaning up, I'm very curious about part 2, so let's go and take a look at part 2 first. What does part 2 expect us to do? Ooh, that's a small addendum. Part 2. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. Yes, this is where scaling, where CPUs will get burned. Cool. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range and the second value is the length of the range. So in the first line of the example above, this line describes 2 ranges of seed numbers to be planted in the garden. First range starts with seed 79 and contains 14 values. Yes. How many ranges do I have in our input? Probably more than 2. Yeah, probably more than 2. Oh boy. This scales up the problem somewhat. Okay, but let's try the naive approach first. So rather than considering 4 distinct numbers, we need to consider a lot more numbers. I think we can trim the search space. I think we can. No, the maps are probably maybe random. Interesting problem. In the above example, the lowest location number can be obtained from seed number 82, which corresponds to whatever. So we still need to find the lowest location number running through the maps. This sounds like a naive approach. Might hit some computational constraints. Let's see if it is the case. So what changes? These are not individual seed IDs, they're ranges. Big old ranges. Yeah, those ranges are really big. And because the maps are like pretty random. Are they random? Yeah, I'm looking at less naive ways of doing this. Interesting. Let's try the naive approach and maybe we'll get a bit smarter while doing it. So I'm gonna grab our example again. I'm not gonna bother cleaning up. I know there's 2 places I need to change. Famous last words. And everything should stay working. But now let's parse our seeds into what? Yeah. Into ranges again. For the naive approach, we can do that. We can do that. So our seeds this is not what we want. So let's take a look at where we define our seeds. Yeah, let's try the naive thing first. So we need to grab these pairwise or 2 by 2, and there's a literal pairwise function to help us. Is pairwise actually what we want? No. Chunk by size is what we want. We can chunk this list in sublists of 2. Yep, and then we have our pairs, and then we can build ranges from them. So I'm just gonna define a new, we actually have a range type, right? I know it was a range with 2 different, it was our entry thing. So yeah, I'm gonna define a new type, range. Start. And length. And that's what we're going to parse into. I'm gonna use array functions to keep it a bit doable. So we have an array. Let's just destructure this. We know it always contains 2 elements. So it's the start and the length. And we can parse that into a start. And a length. And they're both unsigned integers in our world. So our seeds are now ranges instead of individual numbers. There's an unmatched parenthesis, that's correct. So it starts at 79 with a length of 14. And 55, 13, that appears correct. Okay, and then we need to loop over our seeds, but that is not just this anymore. Let's do naive first and then see how far this takes us. We know where this is going, right? So I'm gonna call a function expand, given some seeds, and it just iterates over all the relevant seeds. I'm thinking, could we do like a... No, let's do the naive things first. Are we going to use something fancy here? Nope, let's just do seeds. Flat map. So we can do a map, but then a seed is like a list of ranges, but we just, as output, we don't want like a list of seeds. We just want one big old list of seeds. And if you use a collect instead of a map, that flattens like sublists. It's called flat map in a lot of other languages. So that's what we want to do here. And let's generate a list from range dot. Let's give the type system a hint here. It's a range list. So let's generate a list from range start to range start plus range length. And we collect that into a single list. So I think that's what we want. Let's give it a try. Expand a list from, and a second element that starts at 20 and has a length of 3. Let's see what this gives us. Sorry, field bindings must have the form ID equals expression. Oh yeah, missing an equal sign here. And they're unsigned longs. Yeah, so is this 11 correct or not? That's a bit what I'm trying to figure out here. So let's grab 7914, that's a better example. 79, length 14. That should give us 79 through 92. And unsigned long. Okay. 93, it should be one less, so that's off by 1 right there. And again, unsigned long. I keep making the same mistake. So 79 until 92. Yeah, so this is the naive thing. We can expand our seeds. And just do a lookup chain and find the minimum soil. So in theory, this should work. Were the problem not huge? 64 or 46, is that what we want? That's what we want. So for the example, it's all fine and dandy, but I'm guessing for our input, it might be less than fine and dandy. This is what we're, oh yeah, and the entire thing. I'm gonna grab everything we're parsing and put it closer to where we use it, which is somewhere around here. Okay, sure, why not? Clean up later, clean up later. Let's first make sure that this thing cannot handle our input because too much, the ranges are too big. Probably, maybe. Yes. As we expected, there's a it computes, but it will not end very well. So we might have to become or do a smarter trick to figure out the minimum, which is what we'll be doing. But maybe after a short break. We have been almost on the hour, working for an hour now. Part 1. Really cool problem, part 2 as well, but we need a little think on it. So that's exactly what I'm going to do. I'm having a little think on it, and I'll make a new video for part 2. Yeah, let's go that way. So maybe let's do a quick recap for part 1, and let's stop there. Yeah. So part 1, what did we do? We did a lot of parsing, a lot of map parsing, and this was the data structure. So we had our seed list. And then just our ranges, which was literally what we got in our inputs. No magic there, maybe a bit of chunky chunk. We defined our own little helper function to chunk lists. And for the rest, we didn't do anything too crazy, except maybe building up this lookup chain. That I thought that was a pretty cool way to compose all these lookups. And we thought there was a bug, but it turned out there was no bug. But we played around with how to debug pipelines by plugging in some debugging functions. That's one way to do it. So yeah, fun little problem. Interesting twist that makes us think a bit harder. I'm gonna cut my execution because my computer is freezing up. My computer was freezing up because it needed all those precious CPU cycles to calculate the result, and it could not render video frames anymore. Interesting. But this is where we're gonna pause for day 5. Really cool puzzle. I hope you have fun solving this one, and if you cracked the second part already, please give a shout out in the comments below. I am very interested in how you cracked this computationally intensive puzzle. I'll see you later for part 2, and until then, have a nice day.